Hi everybody, welcome to Unit 2. This is the chapter on atoms, and we studied that chemistry is made of matter, and we learned a little bit about observing matter and measuring matter and energy in our last unit, and now we're going to talk about the smaller parts of what matter is composed of. So what we know is that all matter is made of atoms, and so the beginning of this section tries to trace our early ideas of what we thought atoms were, and our early ideas about matter. And when I say early, I mean early, because really the early Greeks were the first ones to come up with the idea that all matter is made of atoms. And there were two kind of conflicting views at the time. There was this guy here, Aristotle, and Aristotle said, you'll have to fill this in on your thing, that all matter was made of four fundamental elements. And those elements were earth, air, fire, and water. Okay, that was Aristotle. He was really a Greek philosopher. Democritus did not believe this about this earth, air, fire, and water being in all substances. And he said that matter was made of small individual particles that he called atomos. So those were the two conflicting schools of thought. And Aristotle was really highly influential at the time. And because he was so highly influential, he had he was a big wig in the political arena and in the philosophical arena, that he was really believed, and Democritus' ideas were laughed at. So the fact, too, that Aristotle, neither one of them did experiments, but Aristotle could sort of argue his. And he gives his argument here with a piece of wood. He says, when I burn wood, I release the fire inside of it. And some of it turns to air, which is smoke. And the wood turns to dust, which goes back to the earth. So he said that wood was composed of three of his four fundamental elements: fire, earth, and air. So Aristotle's ideas were accepted because he could somewhat prove them with an experiment, whereas Democritus' ideas of matter being composed of these indivisible atoms could not be proved. He had no type of thing to back it up, and he was rejected. Plus, in the political arena, Aristotle was like with the political party in favor, and Democritus was not. So most of the population believed Aristotle. Nobody really believed Democritus, and we went with there were four fundamental elements: fire, earth, air, and water. And it turns out that obviously that's not correct. Democritus was more in line with what the thoughts were. We're going to learn more tomorrow about some other ideas, but in the meantime, I wanted to show you this video. And I'd like you to take out a sheet of paper, and I want you to write down 5 interesting facts from the video. So here we go.
Brought to you by Elements. Building your world one atom at a time.
I'm still recording.
This door, this tie, this keypad, and this guy are all things. And things are made of stuff. Tiny pieces of stuff. Run! No, I mean tiny pieces of stuff. Much tinier than you can see with the human eye. Now look around and count how many different things there are. Yeah, count everything. There's tires and tubes. There's kids and cows. There's wood. And there's forests. There's fish in the sea. There's stars in the sky. There's even kitchen sinks. You can count thousands, millions, billions of things. We call all of this stuff matter. It turns out that if we break matter down, take it completely apart, all of these things are made of just a few things. Imagine cutting a piece of cheese in half. Then, in half again. And in half again. And 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 again. Eventually, you'd end up with a piece too small to cut. There'd be no knife sharp enough. Tiny, tiny pieces that couldn't be broken apart any farther. They'd be unbreak-apartable. We call them atoms. That's from a Greek word that means uncuttable. Atoms are too small to see, even with a regular microscope like this. Here is a model, a first look at an atom. Now here are the main parts. Well, they're particles. Particles, get it? Anyway, in the middle are very heavy particles. And buzzing around the middle are very light particles. Now, if we could see an atom, it couldn't look anything like this because atoms are mostly empty. Take a look at this. It's our proper proportioned giant atom model of science. Now, this part isn't very giant. That's because it's just the nucleus, the middle of an atom. Now, in here are two kinds of particles, protons and neutrons. No one knows what they would really look like. The protons have a positive electrical charge, like a spark. And the neutrons have no charge. They're neutral. They just hang out in the nucleus. Now, buzzing around the outside of the nucleus are very small particles called electrons. Maybe you've heard of them. In fact, the flow of electrons from one atom to another is called electricity. If this vibrating, buzzing ball is the nucleus of an atom, how far away do you think the electron would be? Well, as far as you could jump? No. As far as you could throw a ball? As far as you could run? Well, yeah. Take a look. You can see it from here. It's way out there. The electron would be here. 500 meters. 5 soccer fields from the nucleus. So, everything that's made of atoms, everything that you can touch and feel, is mostly empty space. Empty space. Empty space. Empty space! Now, the electron weighs, a 10,000 of those particles in the middle. And it's going around so fast that it's only here now and then. It's here, and then here, and then I gotta go.
All right, everyone, that's it for tonight. We'll see you tomorrow where we'll wrap up those energy calculations and we'll do a lab and make sure you're all set for your test on Wednesday. The Castle Learning is out there. Have a great night. Bye-bye.